Swayam Prabha. Digital India. Educated India.
So, with that meant the whatever the research projects are there, they actually fundamentally deal with these four kind of the design goals. One is naming the content. Second one is making the routers aware of the names and bringing the ability for these routers to forward the request based on the name and store the names as a part of the routing table and minimizing the latency in accessing the content. If I am able to find the content in one hop distance, so I will be able to get the content quite quickly, and then making the content itself secure rather than establishing a connection to the to a host which is actually having the content. So, with that background in mind, let's explore each one of these requirements in little more detail. So, I said that you require a mechanism to name the content in the information centric networking. Now, how do I name the content? I need to bring a mechanism to name the content. When I say name the content, since the routers are doing the lookup operation, so whether the content what is requested by any of the client exists in their own local store or elsewhere in the network is done by the names. These names need to be globally unique. Globally unique in the sense that on a network of the scale as big as internet that exists today, so where at least if not billions, at least millions of users who are connected to the network are constantly generating the data. So, think of this case, everybody globally is using the social media networks like the Twitter, Facebook, generating the content, uploading the videos on YouTube and many other social platforms. So, everybody's content should have a unique name. So, if the one of the content that I generate and you generate have the same name, then the routers will have issue in identifying the content, whether the client that is requesting the content of me or content generated by you. So, we need a mechanism to name the content uniquely, and that name, the binding between the name and the content itself exists, and it exists, it is a persistent name. It should not happen that for some point of time. So, currently the content, let us say the 1.jpg is the name that is given to some content, some image is the image that exists in one of the client repository or the router repository, and the same 1.jpg is also used for some other image which exists in some other router. So, that is going to create conflict and that we do not want. So, now on a global scale and at least with millions of users constantly generating the data, can we have a naming convention which is actually robust enough to assign a unique name to every piece of content that is generated? So, that brings us to the question of scalability. So, can it scale to that level? So, how many such unique names that I can create, and if at all I can create, how do I create them? There is inherent limitation on how many unique names that I can assign to my own content. So, I can give abc .apg 123.apg, but at some point of time, so I might run out of the names, or the names themselves become quite big, which cause another problem. So, it is not the ability to name. So, even though I can, let us say I can come back or assign a name which is 1000 characters in length, can the users or the consumers remember that 1000 character length name, unique name, and then make a request? So, because the routers are operating only using the names, and if I am using a 1000 character or 1000 bytes name, So it also means that the clients who are making the request also need to remember and or at least know how to systematically query with a name which is 1000 characters or bytes long. So that's achieved. And in effect, the storage and the routing also is happening with the name. So that ability also should coexist with the naming convention that we use. So now let's try to understand how can we assign such a name. So one of the mechanisms that you can use to assign the names to content is something called as the flat name. So flat name is it assigns a standard unique name, something like 1.jpg. There is one piece of there is one name, whether it is 1.jpg or 2.jpg, 10.jpg, 100.jpg, 1000.jpg, whatever is there. So this is a flat name. So what I can do is I can assign such a name to the content. Now how do I know that at least if I want to, let's say hypothetically want to assign a name, if I am the content producer, a name which is 10,000.jpg to an image that I just generated. So how do I make sure that it is the 1000.jpg does not exist in the network? So which brings us to the question that so across all the routers which are connected, which are part of the internet or a network which is as big as the internet, so in none of these routers cache the 1000.jpg exist. So we need to first search, and then if it does not exist, you need to assign the name 1000.jpg to the newly generated content. So that becomes infeasible. Searching in every router which exists in the network is probably not feasible to do. An alternative mechanism to assign the name to the content that is generated is something called as the hashing mechanism. So let's say I generate a piece of the content, maybe an image, maybe a text file, maybe a movie, and this is the content. And what I do is I take this piece of information and pass it on to something called an hashing algorithm, and this hashing algorithm give me a piece of a unique fixed length output. So maybe let's say this gives you 10 bytes of the data, that is also called as the hash. So I take this 10 bytes of the hash, and then I can treat this itself as a name. Now I generated some piece of the data, that's an image, and then I pass it on to an hashing algorithm, and then as part of the naming convention I use hash itself as the name. So I come back and tag this hash to this content itself, and anybody who is interested in getting the content this image that get generated need to query using these 10 bytes of the hash value. Now this is what the flat naming convention is. So now how does an arbitrary user who is interested in some random content is going to know the hash value that get generated? So a compromise between the hash value and the ability of the naming the content the user is to combine the user generated names. So for example, user wants to name this content as 1000.jpeg, and what I am going to do is this 1000.jpeg plus this hash value becomes the name for this content. So at least if the user queries with the 1000.jpeg, then so along with that I am going to put this name and populate in the network. Anybody who queries with the 1000.jpeg as a name should be able to identify all those pieces of information in the network which is tagged with the or at least having the name as 1000.jpeg. So that is what the flat name naming convention actually means. So, this actually flat naming is an idealistic scenario, and in practically implementing that or translating that into reality is become it going to be challenging, because now hash is going to be part of the name itself. Then you still need to make the end user who is querying for certain content, what would be the hash value that is part of the some name. So that is one way of naming the content, and purely this naming content from a generation perspective and also from the distribution perspective is not scalable. The second way of doing the or naming the content is using something called as the hierarchical naming content naming format. What it does is, instead of naming the content as 1.jpeg or 100.jpeg or 1000.jpeg, something like this, I bring some structure to the content that I generate, in the sense that I am going to use a naming convention which is looking much like an URL. So here in this case, tr.nnn and then the slash images slash 1.jpeg. I am going to all the images that are generated are having this prefix. So tr.nnn slash image. So every content producer, if they are generating the image, will have such a prefix used. So if I am generating, I might use a prefix which is ending with image 1 and then the different images of my own. I can still use the 1.jpeg, 2.jpeg and 100.jpeg, as many images that I can create. But whatever the content that I generate is having the common prefix as this one. So someone else might have the prefix which is looking like this, tr.nnn.images 2.1.jpeg. As long as the prefix of mine and that user is different, then the routers in the network will have no problem in uniquely identifying the content. So purely this mechanism of naming or naming convention is scalable, and as long as every distinct producer has a unique prefix assigned to it, then I can go and query that content and figure it out where exactly that content is. I can borrow that content and then deliver it to the user. So this mechanism is somewhat similar to what is done in the current IP network. So IP networks uses the IP address as the means for locating the content or borrow the content from that particular location, and it uses the IP prefixes, and the search operation itself is done using the longest prefix matching technique, and it also uses the routing aggregation. So the common prefixes you take together and then you condense them and then put it into vision. So the same mechanism can also be used here as well. So for example, if there are two producers P1 and P2, and if these two producers share a common prefix which is looking something like this, so maybe he is having the prefix XYG slash PQR and then PQR maybe 1 and then 1.jpeg, 2.jpeg, something like this, and XYG, the second producer has got XYG PQR 2 as a prefix, and then he can name the content. So if these two producers are connected to two different routers R1 and R2, for a router let's call this as R1 and this as R2, and a router R3 is connected to both R1 and R2, and R3 might store a kind of the common prefix for both R1 and R2, or if both R1 and R2 say are on the same link, somewhere here is the R1 and somewhere here is the R2, then both the request or both the prefixes are going to the same next of router. So then I can use a common prefix which is XYG dot slash XYG something, something like XYG star. So anything that is originating when the client makes a request, irrespective of whether it is xyz/pqr1 or xyz/pqr2, I still send it to the same outgoing link or on the same next stop link. So, in effect, what I am trying to do is here the condensation or the aggregation of the unique names that exist in the globe exist in the network. So, that is possible if you use a structured naming conventions like the hierarchical naming convention. And the third way of looking at the or generating the names or assigning the names to the content that get generated is something called as using the attributes. So, every piece of information, so be it the image or the text or the movie or the whatever your content that you generate has got some attributes. So, attributes in the sense something might be the size of the file, something might be the type of the file, whether it is the JPG image or MPEG image, and length of the file, and whether it is a high definition video or low definition video, whatever it is a compressed video. Coupled with the name of the author, these are all some of the possible attributes. You take these attributes and then using that as an input, you pass on this to think of this as these are different attributes that are passed to a function, and that function come up using all these attributes comes back with a unique name, and that name you assign to the content and populate in the network, using which the consumers actually subsequently raise the request and get that content. So, let me summarize. Flat names use hashing mechanism, and then they are flat names are not only poses challenges for naming, it also poses challenges for routers to navigate and locate the content. And if you have flat naming convention, then the sheer number of the unique content that get generated, at least on a network as big on a scale as that of the internet. So, there are many at least millions of unique content get generated every day, and storing those many number of unique contents in every router is going to be quite a challenge. And on the other hand, if you use the hierarchical naming convention, so you can bring some notion of the structure, and then you can aggregate the names using the common prefixes, and then you can do the forwarding and the lookup operation. And the third way is to look at the attributes that are existing with the data itself, and you take these attributes and then you generate the unique name to the content that get generated. So, these are the three possibilities that exist. So, that is one way, one challenge that we wanted to address in the information centric networking, which is the naming the content. The second mechanism that we want to address is something called as the caching mechanism. So, meaning, as I said, as the content moves from the producer to one of the recipient, all along the path the routers can make an independent decision to cache the content. Now, the question is, if every router in the network starts to cache the content generated by every producers that exist in the network, then how much of the storage capacity the routers need to have? And and clearly it is imperative that every router cannot actually cache the content that is existing in every or generated by every producer in the network. There is some limit on the how much of the storage capacity you can put inside the router. So, that brings us to the question, so at what point of time the router makes a decision to cache what content? So, is it based on some rational argument, or what is important to cache? If I am discarding something, then on what basis I am discarding something? So, those decisions we need to make. So, that is what is called as the intelligent caching and the storage. And in effect, by storing the content closer to the consumer, we are improving the response time, but that comes at the expense of the storage cost. You want to put the storage at every router. So now I can trade off. So the more the amount of the caching ability that I have, more the capacity I have in the routers, more the content I can store, and that improves the response time. But on the other hand, so if my cache is limited, then I am going to probably, if I don't have it, then I need to ask my own neighbor. So you need to cross some number of the hops in order to get the content. So there is a trade-off. Now I want to minimize the response time, and at the same time I want to store more number of the unique contents, as many unique content as possible, so that I minimize the number of the times I actually go to the end producer to get the content. That's the objective. Now this can be achieved by a kind of the strategies which broadly fall into two categories. One is called coordinated mechanism to do the caching. So coordinated in the sense that, assume this, if there are 3 routers or n number of the routers in the network and they are connected in some fashion, and if the R1 knows some piece of the content C1 exists in R2, and since R2 is the direct neighbor of the R1, and when the same copy C1 is actually passing from some producer P1 to some consumer C1, receiver, maybe you can use another name, some or S1. So if C1 is going from here to here, and then here to here, and then here to here, and R1 can notice that C1 already exists in R2, and probably R3 might have also cached the copy of that content, then probably R1 may decide not to cache that content C1, although idealistically we wanted it to be cached at R1. But since there is a cooperation, so we want to judiciously utilize the collective storage capacity, the collective capacity of all the caches that exist in the network to reduce the latency of the access for the end consumers. So if the routers in the network use such a mechanism to coordinate among themselves to intelligently decide what to cache and what not to cache, so that mechanism is called as the coordinated mechanism, or some kind of the cooperation exists, and then so that maximizes the utilization. So more diverse content you can actually put into the network. What I mean by that is, so if every piece of content is stored by every other router, then when the capacity at the R1 gets full, you need to, if new content comes, then you need to discard some of the existing content and store the new one. So there is a recycling mechanism. When the storage gets full, then you discard some of the old content that exists in your local storage and then store the new one. So that also brings us to the question, what to discard. So it's not only what to store, but what to discard, and what point of time I am going to discard, that we have to decide here. So this is what the convention. So on the other hand, if every router is making its own decision independently whether to store a particular content or not, irrespective of whether their neighbors having the same copy or not, is called as uncoordinated mechanism. So again there is a trade-off here. If you use the uncoordinated or the second method, then the operation becomes simpler. Every router don't have to bother about what its neighbor is doing, and then if I want to cache it, I will just cache it. If I don't want to cache it, I will not cache it. If I want to replace something, then I will replace it on my own, and if I don't want to replace something, then I decide on my own. So the operation is simple. On the other hand, if you use the first method to do the caching and the replacement decisions, then you need to know constantly at maybe at every regular interval of time, you need to go and find out what is there in the router R2's cache and what is there in the router R3's cache. Now the question is, how far I can go, whether it is only one hop neighbor or two hop neighbors or n hop neighbors, that's the question. So again, the more the number of the hops you go away you go on, and so the more the diverse content you will be able to store in the network, and that comes with the expense of the communication, which is just used to find out what is there in this neighbor's cache. So even though consumers may not have asked any data, still at regular interval point of time, I need to go, and the router need to go and check what is out there in neighbor's cache. So again, this I'm going to make intelligent decision to cache and evict the content from the local cache, but that comes at the expense of the some communication overhead. So what I can afford, whether it is the communication overhead or the ability of the storage that I want to put inside the router, that trade off or the decision need to make. So that is the second the objective that we want to bring into the information centric networking.